Hi. Hi guys, please text the rest, tell them to join quickly.
Okay. Miss Nisma, did you answer the questions on the graph?
The answers what?
Did you answer the questions on the graph? Did you answer them and check them?
Yes, you can check. I will upload the video right after this session. You can check it then, okay?
Okay, thank you.
You're welcome, dear. Okay, now I need you to open page 60, guys. Page 60.
Miss, I didn't finish the last question in page 59.
Okay, you can check also the recorded session, dear. After finishing this, I will put the session on Classera. You can check it. All right? I want you guys to open page, or let it be 62. Open page 62, please. And let's start. I know you said you told me like 100 times that you finished the whole thing. Okay, so page 62. Okay. And this means that your homework will be 61, 60 and 61, 64 and 65. Okay. 60, 61, 64 and 65. They are really easy. Yes.
Why did you started giving us a lot of homework?
Because we need to finish. There's a lot of missing because the Sundays were all of them were vacation, and all of your doubles are in the Sundays, so you're really way behind, and this is why I give you a lot of homework to finish and then we answer it together. It's much easier this way, because if I did it as a classwork, it's going to take a lot of time. Okay. And there I'm looking for the easy stuff to give you as a homework. Okay, so in page 62, class 6 are investigating how long it takes heat to travel along rods made from different materials. Class 6 are investigating how long it takes heat to travel along rods made of different materials. What does that mean? Okay, let me explain the idea to you first. Now, right there, this is the model that they are doing in order to do the test with. What's the idea of this model? They bring a tray full of sand. Okay, they bring a tray and they fill it with sand. And then they put a stand, something that they can support the rod on. So this stand is only something that they can put the rod on. And then they put a candle next to the stand. Okay. Now this rod, they fix it, or they put it on the stand, and they try the test first with a rod made of, for example, plastic. And then they remove the rod and they put a rod made of steel, for example, and they make the test again. And then they remove the rod and then they put a rod made of rubber. and then they remove it and so on. They are trying different materials with this rod. Okay, now at the end of the rod, as you can see, they fix a paper clip. They stick a paper clip to the rod. How do they stick it? Using a piece of wax. So they put a piece of wax here and they stick the paper clip to the rod. And then they put the candle under the rod and they wait for a while. They see when will the whole rod will be hot, which will make the wax melt and the paper clip fall down. And they measure the time that it took the paper clip to fall down. This means that they are measuring the time the whole rod became hot. And why will it make a difference? Because if it's made of an insulating material or a conducting material, it will make a difference. The time taken for the paper clip to fall will be different according to the material the rod is made of. Do you understand, guys? Do you get it?
Yes.
Yeah.
Okay. Now let's start from the beginning. It says class 6 are investigating how long it takes heat to travel along rods made from different materials. What scientific name is given to materials that allow heat to travel along them? Ayman.
Thermal conductors.
Yes, thermal conductors. Very good. The next question is, please write down quickly. I need you to write down quickly. Okay. Okay, I will move to the next question. The next question says, the candle heats up the rod. The heat travels along the rod to the wax. This is what I was just explaining. The candle heats up the rod and the heat travels along the rod to the wax. When the wax melts, the paper clips falls off. Class 6 measure the time it takes for the paper clip to fall off. What force? This is related to the previous lesson. What force causes the paper clip to fall into the tray? What is the force that is pulling things to the ground? Habiba.
Gravity.
Gravity. Thank you so much. All right, gravity. Now, page 63. Finish writing quickly, please. Page 63. Okay. Page 63 says, class 6 record the results in a table. Fill in the missing heading on the table of the results. They don't want you to write results or the type of the material. They want you to write the heading. What is that column represent? This one represents time taken for the paper clip to drop. What does this column represent? Yes, Layan.
Yes, miss. It was material of paper clip.
Of paper clip?
I mean of the rod.
Of the rod, thank you. The material of the rod. The material of the rod. Very good. Thank you, Layan. Next question says, the heat traveled along the rods at different speeds. And we know why. We know that because of which type the material is made of course, the paper clip will fall in different speeds. Put the materials in order to show how quickly heat traveled along them. Write copper, glass, or steel in each box. You can use the table above. They wrote how much time did it take the paper clip to fall according to each of those materials. Okay. So let's see Jaida. Hey, Jaida. So which which material the heat traveled slowly along it? Slowly. Slowly means that, yes, slowly means that it took the most amount of time.
The glass.
Glass, exactly. Very good. Glass. Okay, and then continue, Jaib.
And then steel.
Then steel, and the last one is?
The last one is copper.
Copper. Excellent. Okay, the next question says, how could class 6 make sure the results are reliable? Now, I want you to get used to this type of questions, because this type of question, you will see it everywhere, including when you go to year 6, you're going to answer it in the past papers and even in the checkpoint. This is a very common and famous question. It is related to the scientific method lesson. How could class 6 make sure the results are reliable? I will ask you a question, guys. Now, you made a test in the lab, for example, and you want to make sure that you made the test correct. What will you do? Will it be enough for you to make the test one time, or should you repeat it several times and collect the results several times? Yes, Habiba.
I just want to ask a question.
Yes.
What means reliable?
Reliable means accurate. Do you know what's the meaning of accurate?
No.
It means that they want to make sure that the results are correct.
Oh,
Okay.
thank you.
You're welcome. Okay. Tayyim, what do you think they should do?
I think like
Should they make the test only once, or should they repeat the test?
they should repeat it.
Yes, exactly. And this is the answer for this question whenever you see it, guys. How could the people who are making the test make sure of the results? They just have to repeat the test. They have to repeat the test. All right. Now we're going to the last question, which is question F. Look at the table again. Write true or false next to each statement about class 6 investigation. All right. Should I erase everything?
Wait 1 second.
Okay, make it quick, please.
Okay. You can erase.
All right. Where did the rest of the class go, guys?
Maybe in the snack.
All this time, why they will have like a 40-minute snack or what?
Miss, can I tell you something? We have no snack. We have no
I
snack.
know. I just gave it to you as a privilege.
Yeah, I know.
To see how good am I. And because actually tomorrow I will take a session, an extra session for you guys. So, yeah, exactly. So I'm trying to be a nice person. I'm trying to be a nice person. All right. Look at the future mics. Look at the table again.
It's okay.
Write true or false next to each statement about class 6 investigation. The heat traveled quicker along the metal rods than along the glass rod. Yes, Saif? Do you think it's true or false? The heat traveled quicker along the metal rods than along the glass rod.
True.
True. Yes. True, of course. Okay. Next, the one variable class 6 changed was the time it took for the paper clip to fall off. What does the word variable means? It means the thing that they changed with their own hands during the experiment. I mean, for example, you're testing at what temperature will the water start to boil. For example, this is your experiment. You want to test when will the water starts to boil. So what do? You keep adding on some heat to the beaker filled of water so that you can make the water reach the boiling temperature. So this is what you changed. You changed the amount of heat the water is exposed to. This is what you changed. This is the variable that you changed. And what is the variable that you're measuring? The temperature of the water. Okay, this is what you are measuring. Now, what are you going to keep the same to make the test fair? The amount of water in the beaker, for example. This is something that you should keep the same. Okay, so the one variable class 6 changed was the time it took for the paper clip to fall off. Is this something that they changed or something that they are measuring? I want you to think about the question. Is this something that they changed or is that something that they are going to measure? I will take Bilal. Bilal. Yes. Unmute your mic. Yes. The one variable class 6 changed was the time it took for the paper clip to fall off. Is it true or false? Did they change the time it took for the paper clip to fall off, or are they measuring the time it took the paper clip to fall off?
Measuring the time down.
Yes, so they don't change it. They are measuring it. This is something that they cannot control.
False.
So the answer is false. Very good. Okay. Thank you, Bilal. Next, Omar. The one variable class 6 measured was the temperature of each rod. Did they measure? Yes.
Can you hear me?
Yes, I can hear you, dear.
Okay.
So the one variable class 6 measured was the temperature of each rod or the time taken for the paper
Time taken.
Yes, the time taken. So this is true or false?
False.
False. Very good.
B. Miss, look, I made an experiment.
You made an experiment. Show me. Where are you?
There is in it water.
Oh my God, this is very weird.
Can you see?
I know this experiment.
Yeah. It has water and the water is not falling.
Yeah. Wait.
No.
1 second.
Okay, I really need to start doing the next.
Please start.
Okay. All right, guys. So now your homework will be pages 60, 61, 64, and 65. They are really easy. Where one word, or something that you will pick. So there is nothing that you have to worry about. Now, I want you guys to text the rest of the class because I'm going to start the new lesson.
Okay.
Okay? So please text them, tell them that they are very late and they need to come back. We have like 13 minutes left or maybe less, 10 minutes. All right, guys. So the lesson that we're going to take now is a very easy one, and I think you have an idea about it, which is the magnets lesson. Do you know magnets? Of course you do know magnets.
Miss, why are we taking that? We took it last year.
Okay, we're going. All right. So consider it like a revision or something. Okay. Okay. So
why are we taking the same lessons?
So guys, those are iron nails. Please mute your mics now. Those are
Magnetic.
iron. Please do not speak while I'm speaking. Okay? It it shut off. Thank you, Ayman. What did you do?
Miss, I didn't do anything.
I know, but it shut off.
Yeah, but I didn't do anything, I swear.
I will try to believe you.
I swear I didn't do anything.
Okay. So we have, you know, the iron nails that we hammer to like fix anything on the wall and stuff like that. So those iron nails, guys, are made of particles, just like any other material in the world. So they are made, yes, I can see Omar. Perfect. You're a magician. Okay. So the iron nails are made of particles, and those particles are arranged in a specific way. Okay. Now, once the thing that the scientists and people who are really into chemistry noticed that, guess what, the particles arrange themselves in a specific way once they approach a magnet. Omar, it's okay. Now we're doing something serious now, okay? So, as I told you, any matter is made of particles. So the iron nails are also made of particles. This is how the particles of the iron nails look like under a microscope. As you can see, they are not really arranged in a uniform way, okay? Now, once we put a magnet near the iron nail, this is how the particles inside the iron nail looks like. See, they got really arranged in a very neat way, okay? So when I bring a magnet close to an iron, what happens? Does it get attracted to the iron or not? Huh? If I put an iron nail next to the magnet, will they get attracted to each other? Yes, they will. Yes, they will. Okay.
Yes.
Omar, I'm really thinking about closing your video, your camera. Okay. Yeah.
Miss, can I go get something and come back?
Okay. So what happens to the iron particles? The moment the magnet come closer to it, and this is why it gets attracted to the magnet, the particles inside it gets lined up in a straight line. This is how they react to the magnets, okay? Now let's talk about the types of magnets. This is very easy. This part is really easy. We have a lot of types or shapes of the magnets. You have this one called the rod magnet. This one is called a bar magnet, and this is the most famous one. This one is called a horseshoe because it looks like a horseshoe magnet. This is another shape of it. This is called a ring magnet, and this is called a wand magnet. It looks like a witch wand. You know, the piece of or the stick that the witches use in order to make like magic. This is a wand magnet, and this is called a disc magnet. And this part, this one, you can find it where, do you know the purse of any women or ladies?
Yes.
Yes. So once they, if they want to close it, some of the purses have this magnet that makes it get closed, or that you can close the purse with. Have you seen it before?
Yes.
Yeah. Okay. So those are the different shapes of magnets. You have rod magnet, bar magnet, horseshoe magnet, ring magnet, wand magnet, and disc magnet. Okay. So this part is really easy. There is nothing that we there's nothing hard about it. So I want you to open page 75, please. Open page 75. Page 75, okay? So in page 75, I'm just going to open it. Okay, the first question says, name the type of each magnet. So I will give you like 1 minute to finish writing all of them.
Miss, what is the page?
Page 75, question 1. Page 75, question 1. Okay. People keep using the chat. Okay, thank you, Omar. Okay, so yes, Ayman, please tell me what is the answer for the first one. What's the name of this magnet?
Horseshoe magnet.
What? The first one?
The first one?
Hmm.
I still didn't do it. I
Okay.
started from the bottom.
Okay, who knows it?
Because I started from the bottom.
Who knows it? Jaida? Yes, Jaida.
Yes. Bar magnet.
Bar magnet. Very good. Thank you. The next one, as Ayman said, is the horseshoe magnet. Very good. The next one, huh? Who can tell me what is the name of the first one? Yes, the third one, sorry. Liane?
It's the wand magnet.
Wand magnet. Excellent. What about the next one? Huh? Habiba?
Yes, me.
What is the name of this one? Something that you put in your finger. Something that you wear in your fingers. What's the name of the thing that you wear in your finger?
Miss, can I say?
You don't put anything in your fingers?
No, like it's
Ring.
What do you put in your finger?
I said it's a ring.
Ring, exactly. Ringed magnet, exactly. And the last one is, Saif,
And
can you tell me?
Somebody said the answer.
Yeah. The last one is?
I can't remember it.
Rod. Yeah, rod magnet, okay? So the first one is bar. The second one is horseshoe. The third one is wand or wand. And the fourth one is ring. And the fifth one is rod magnet. Okay, did you finish? Did you finish
Yes.
writing? Okay. That was the... What? Do you need some? Page, that was page 75. That was page 75. Okay. Now let's continue, guys. Let's continue. What will happen when you when the ends of the two bar magnets are placed together? Okay, this one is also very easy. This is something that you have learned about. If you haven't, then you at least you have tried it before. Sometimes when you bring two magnets close to each other, they stick to each other. And some other time, yes, please mute your mics. Please mute your mics.
The next session started.
It's still, it's 10:59. I have 1 minute left.
10.
Okay, so you bring them closer to each other and the magnets stick to each other. And some other times when you bring the, please do not interrupt me with anything. And people are starting to leave the session. This is very, very rude. So you bring the magnets closer to each other, they stick to each other. And some other times when you bring it closer to each other, they repel from each other. They start to push each other away. Okay, so we're going to stop here and we're going to start from this point tomorrow, guys. Okay, so I'll be seeing you tomorrow. Bye, guys. Bye.
Bye. Bye.